Hello YouTube, it's 10 minutes with hb9fxq. First of all, thank you very much for the great feedback for the first video, and as of now we have about 5,000 impressions, and that's amazing. Simply amazing. I'm really happy and really glad to continue with the series, so it's really motivating, and thank you for the critiques, because the critiques are important to improve the quality of these small episodes. So, for today, I've prepared an SDR related topic as well. To be honest, I'm somehow addicted to this SDR devices, and yeah, I love the technology, and so today it's about this nice device here, the Flex 6500, and I have a small setup here. I didn't want to do a product review, the next product review on YouTube. I wanted to prepare for a remote setup. And the remote setup, here I've got some cards and I'll just collect them to show you what it's about. So, to go a step back, the situation at my home is I'm not allowed to have a permanent antenna setup. And yeah, that's somehow the situation currently, and a solution would be to have a solid remote setup. Now, a remote setup, in my eyes, it's important in matter of three aspects. The first, it needs to be secure. You have to go and ask for permission to operate it, yeah, you need a reliable and secure setup. This is the second aspect, the reliability. I want something to simply work without juggling around with a lot of technologies like Skype and remote desktop and maybe some cut devices for remoting, and yeah, I'm trying to reduce the setup on the necessary stuff without any compromises. And the next aspect is performance. It really needs to perform, and I want the feeling as I'm sitting directly at the radio. So the Flex 6500, we're connected to the radio by a single plug, and it's an Ethernet plug, and that is amazing. So as of today, there are rumors and some announcement, I guess, that the radio will be internet ready in an upcoming version, and that means you can maybe, I don't know, maybe plug it directly to your router and have a remote enabled connection. But since today there's nothing like that that is officially announced, I had to prepare it on my own. So you see there's a computer, and the computer is kind of the gateway between the internet and the internal network that allows me to interact with my radio components. So the setup. On the outside there's the internet connection. For red here you see the white wire that goes to my router, and then here we have a laptop in front, and the laptop is not connected to any of these networks and no wireless network. It's just here on my cell phone. I have an hotspot here, and it uses a 4G internet connection, and it's like outside. I mean, this could be anywhere, at home, 4,000 kilometers away, wherever. It doesn't matter. So let's put the yellow card here, and our goal is to get to the radio. And to get to the radio through the computer, we get into this green zone here. That is the color here in this case for the internal network. We have a network switch, small one, that is connected to the second Ethernet port of the computer. It's 2 ports. And this will be our green side. And on this side, the internal network side, we have this one here. It's a switchable power plug that has an Ethernet connection. It goes to the switch. And on the other side, we have the power for a relay here. The relay will switch on the radio. And we have directly the radio connected to the switch. So fine, so far. The reason for this relay here is we are not on site and I don't want to have the radio be switched on 24/7. In case of an error of the radio, that might happen. I have not seen it yet so far, so I'm happy, but you have no chance to quickly power cycle the radio or something like that. So, yeah, the radio's power supply here, of course, plugged to the switch as well. There's a cinch connector on the back of the Flex radio here. And well, let me try to get this on the screen. So it's called remote on. In the manual here, it's remote on. And when you close this circuit here, it'll have the same effect as pushing the power button on the radio. So last but not least, there's a camera. The camera is facing currently here to the front of the radio because in case of an error, you don't have a chance to just quickly, maybe not, depends on the distance, but doesn't have the chance to quickly jump to the radio and look at the display to check the error code. So green network as well, a small network camera, and it has these infrared lights on the front to be able to see the radio even in the dark. So green zone here as well. Okay, the computer runs a Linux distribution, a small server distribution, and there's an Openvpn service running. So on the one side it gets an IP address from the router, and the router has a port forwarding to the port exposed by OpenVPN. Yeah, nothing special. I guess there's a lot of manuals out there. There's just one hint. We'll check that later, what to do to have this setup here working with OpenVPN. I would suggest we take a test drive how these devices are operated. Okay. Now at the computer, and you see I'm on a cellular network 4G connection. Just doing a quick performance test. We have 34 megabits down and enough up. So the thing is like this. The upload connection is critical on the remote side because it needs to push more data to the client than you need to push data from the client to the server. The protocols used for audio and the Waterfall and the pan adapter data, spectrum data, are not really compressed. So the audio is pretty efficient, but all other stuff is not really compressed, and a part of the compression is handled. So we have 32 down. Okay, so let's close that. Most compression stuff will be done by OpenVPN itself. It has the capability to do compression. It depends on the data how efficient the compression is. So in our case, we have a lot of text-based protocol. Text-based, yeah, of course it's binary, but a lot of text going on between these two sides, and the compression is pretty efficient. From my measurements, we might take a look at the measurements as well. It needs roundabout 3 megabit per slice. Download on this side, upload on the remote side. So, but let's get to the practical part. On the computer I have a Openvpn client, and the Openvpn client knows the remote site by its IP address So what you need on your remote site is either a fixed IP address, a static public IP address from your provider, or you need some kind of dynamic name service like DNS or stuff like that to be able to reach your remote site. To know the address. So in this case, I've got a static address, and I'm now going to connect to it. And what it says, it's does it work? Yeah, okay. Reliable. Yeah. We are now connected, and we are on this switch. So this computer here should be able to reach this this computer. Right. Nothing is switched on. You see the power supply is off, no fans here. The address of the computer is now from the internal range. So here's the DHCP server running, and it has the computer itself has the IP address 10.0.0.4. And okay, what you see here is I've prepared a small interface, and on the interface I'm directly looking at the camera, and the camera is facing to the front of the radio, so it's switched off currently. In the back, the most important man for today, it's my son, and he's operating at the camera and doing a good job. So okay, keep the focus, okay? Yeah, fine. Okay, now I'm switching on, and there's a small Python script here that sends a command to the power switch, and first it switches on the power supply. The radio gets a moment to get started, and now you hear the fans are switching on because the relay has switched on. This is a signal for the relay, and to protect myself from ugly switch operations where I could maybe destroy the radio, because the radio has a startup and a shutdown process, and I wanted to keep the sequence. So there's a plug for an active loop antenna as well, and the relay and the power supply. And the sequence is switch on the loop and the power supply, wait a few moments, then switching on the relay. And when everything is running, up and running, let's see at the front, the webcam, you should see it in a second. Yeah, now there's my call sign on the display. That means the radio is switched on. And basically that's it. So now Smart SDR discovers my radio, and we are ready to go. So what we see is the IP address. No, we don't. Oh, well, we do. 10.0.0.14, and the radio got the IP address from the computer. We're gonna just start it, and now don't worry about the signals here. Just turn off the speaker. The antenna for today is a mobile antenna, and it's just outside of my office window, so don't expect wonders. But as you see, it works. And in Smart SDR, we have an indicator down here for the quality of the network connection. So on 4G, there's some latency, and the ping was about 30 milliseconds. So the indicator varies between yellow and green, but that's absolutely fine, what I've seen. The audio comes in, and when we take a look at DAX, for Flex users, they know DAX. It transports the audio, and that is working fine as well. So this setup is simply like you're putting, it's physically comparable to physically putting your computer directly to the switch where the radio is located. And yeah, here for today it's just a little bit to show it works. It does work in both directions. I won't do any transmissions today because of the antenna setup. It's guess it's not recommended to do it. So, but even this cellular connection is capable. Oops. Is capable to operate 4 slices at a time, and the performance is fine. So if you're on a lower connection, you're able to reduce the data used by decreasing the amount of data by reducing the frames per second for the it might be too small on the camera. I'm gonna close this the 3 to have 1. So if we decrease, oops, the second slice, sorry. So okay, display, sorry. Average frames per second. When we reduce this, you see the pan adapter display slows down, it gets less data over the line, and I can reduce the rate of the waterfall. But yeah, somehow this simple connection allows me to operate at full speed, full resolution, and it's a full HD display, so it has quite a huge dimension. Let's take a look at the band. So I'm fine with it. For transmission, I have reduced RF power to 0. Just make sure that your microphone is selected as an audio source, like the internal microphone on my notebook here. And be sure to select PC here. Be sure remote is on. So RF power is at 0, so I'm not going to effectively transmit. Press MOX, but so you see the indicator up here indicates that the audio is coming in to the radio. And I've had a few QSOs with this setup. Even over the cell phone, I had great reports. I had a USB headset connected to the computer, and no issues with the incoming or outgoing audio so far. Well, yeah, that's great, and basically that's it. And I think the next step would be to reduce the size of this machine, to a smaller device, and find a good new home for my equipment. So if you know a good spot anywhere, I would be happy to place my radio over there. But even for home operation, when you have the Flex at home and you want to use it on the road, then leaving a computer on is pretty valid solution for accessing the home radio. Great. The shutdown sequence, basically the same. We'll leave this open, go back to the browser, and I click on shutdown. It switches off the loop. Okay, the camera is gone. Then it switches off the relay, and when the relay is switched off, the shutdown procedure starts on the radio. You might have not seen it on this small display here. And at the end it will switch off the power supply after a while. So okay, let's conclude this setup, the information. Basically the video is just showing that Openvpn in combination with a smart SDR is working fine, quite out of the box. The only modification I had to do on Openvpn was the default setup uses a UDP-based tunnel, UDP as a network protocol, and I had to switch it to a TCP connection, TCP-based connection. I had issues with the performance, and the TCP connection might have a bit more overhead, but it works pretty reliable, as you see. So to conclude, I guess there are some things important and to keep in mind. The reliability. If you put your radio remote and a computer on the internet connection might break away, and you have no longer the chance to switch off the radio. Depending on the state of your radio, don't know, transmission, I don't know what happens when you plug out the Ethernet connections while transmitting. It might switch off, or might occur, an error might occur, and you need to power cycle the radio immediately. There are several switchable power plugs here available, IP-enabled power plugs available, and this one here has a special feature. It has a keep alive function and is able to send out a ping every few minutes to a host on the internet, and if the host isn't reachable, you can tell it to switch off the power plugs. And I think that's an important feature. When the internet breaks away, the PC can still be running, doesn't matter, but you want the radio to switch off then. And that is guaranteed with this one here, this device. It's from Untitled Electronics. I'll provide the link in the video. So, and another thing is the computer, the power might be interrupted. And I've set it up, this computer, to switch on power return on the back. So if it has a power loss and it comes back again, the computer starts automatically when it has power again. And yeah, be sure to have a restart safe configuration. So on this Ubuntu machine here, it's not an issue. The Openvpn server is set to start up automatically on boot, and yeah, basically that's it. So for convenience reasons, I mean, you could have used the web interface of the power plug, but for convenience reasons, I've developed this small front end here to power cycle these devices, and yeah, might not be useful, as well as the webcam to have a look at the display. Okay, so I'm gonna switch it off now, and I have to switch it on again because I want to give you a sneak preview. Currently, this the operation of the radio requires to use Smart SDR. There are some other experiments out. I guess there's an iPad application, but I don't have an iPad. I'm a Linux guy, and I'm interested to run my Linux client machine for ham operations, and not need to be bound to a Windows machine. But yeah, there's currently no software, and what is available is there's an API, a well-documented API for the radio, and I've done a little experiment with the API, and I hope it works. I want to show this now. Well, the remoting with Smart SDR has proven to be working, and yeah, the future in my eyes is still HTML5. I have prepared a small experiment. It's a very early prototype, so not much to expect. But what now happens is I have started a small C# application that is using the FlexLib to connect to the radio. And it has now started a pen adapter and subscribes to the waterfall of the pen adapter. And the waterfall tiles are then pushed to WebSockets, and with a bit JavaScript magic, HTML5 canvas element. So we now, and that is, in my eyes, that's amazing, is a waterfall in a browser, and look at the performance. It's quite like in a native application. Now my poor Office antenna is not the best demonstration setup for today, but anyway, you see it. When I now open Smart SDR, you see it has started a pen adapter here, and when I now increase and decrease the width, you see it in a browser, the pen adapter adjusts just to here. Okay, all right. So I'll increase the width again, and So, and I think this is the future, and yeah, I'm looking forward to invest more time into this HTML-based programming by using the API of the device, because yeah, the vision of having any device with a decent browser being able to connect to the radio and control the radio, yeah, it's just a matter of time to complete this, because the API has all the capabilities the application has, and now the job would be to transform it into web technology and adapt it to web technology. So I think that's all for today. If you have any ideas of things you want to see or want to learn, or you think I should integrate in the upcoming videos, please let me know. I'm very excited to read the feedback for this video, and hope to see you the next time. This was 10 minutes with hb9fxq. See you again, 73s. Bye bye.